Atomic zoom in, comparing substances at a very small scale. Imagine you're eating breakfast. The wooden table you're sitting at is hard. Your orange juice smells sweet, and the sugar in your sugar bowl is white. The day has just begun, but you've already come into contact with many substances, each of which has its own set of properties. What is it that gives these substances their different properties? To understand where these differences come from, scientists observe substances at a very small scale, much smaller than we can observe in our daily lives. Let's zoom in and see what we find. What is matter actually made of? In the 1800s, John Dalton was the first to propose the idea that all matter is made of tiny pieces called atoms. Today, we call this the atomic theory. Since it is a theory, it may sound like scientists are not sure about it, but a scientific theory is an idea that has a lot of evidence that many scientists have gathered over a long time. Even today, scientists continue to gather evidence that all matter is made of atoms. Atoms are too small for us to see, but scientists currently know of 118 different types of atoms in the universe, including oxygen, carbon, silver, and gold. Every substance is made of a unique combination of atoms. Substances can be made of just one type of atom or a specific group of atoms that repeats over and over. Chemists represent these groups of atoms using chemical formulas, letters and numbers showing the types and numbers of atoms that repeat to make up a substance. Substances have different properties because they are made of different types and numbers of atoms that repeat. How atoms make your orange juice smell good and your socks smell bad. Have you ever noticed how good orange juice smells when you pour yourself a glass? You may be surprised to learn that for many brands of orange juice, that aroma is added. Orange juice is often kept in big tanks for a time before it is packaged and shipped. The juice needs to be processed in order to keep it from spoiling. This processing can cause the pleasant orange scent and flavor to fade. To address this problem, chemists add a substance that makes the packaged juice smell and taste like fresh squeezed oranges. That substance is called ethyl butyrate. Ethyl butyrate is a naturally occurring substance found in many fruits. If you examined a sample of ethyl butyrate, you might observe that it is a clear liquid with a strong smell of pineapple or orange. It has a chemical formula of C6H12O2, which means it is always made of groups of 6 carbon atoms, 12 hydrogen atoms, and 2 oxygen atoms. This group of different atoms forms a pattern. It repeats over and over again to make up the substance. The more times the pattern repeats, the more ethyl butyrate you have. Even very small differences at the atomic scale can have important effects on the properties of a substance. One substance that is similar to ethyl butyrate at the atomic scale is called isovaleric acid. If you were to observe the properties of isovaleric acid, you would also see that it is a colorless liquid, but you would never get it confused with ethyl butyrate. Why? Instead of the pleasant smell of citrus, you would smell something similar to sweaty gym socks. Gross. Why do these two substances have different properties? Looking more closely at the atoms in isovaleric acid, you can see that it is made of groups of 5 carbon atoms, 10 hydrogen atoms, and 2 oxygen atoms. So its chemical formula is C5H10O2. Ethyl butyrate and isovaleric acid have different properties because the atoms that make up each substance are grouped differently. Isovaleric acid has 1 fewer carbon atom and 2 fewer hydrogen atoms. These atoms are also arranged in a different pattern. At the atomic scale, these seem like small differences, but even small differences are enough to give the two substances very different properties. So here we can see ethyl butyrate and isovaleric acid in their molecular forms. Are these diamonds real? Chemistry and jewel trading. Diamonds come from deep inside Earth and are often polished and used in jewelry. Because they are very popular, they're also very expensive. Due to the high price of diamonds, Jewelry makers sometimes use substances that share some of the same properties as diamonds, but cost less. One of these materials is a human-made material called cubic zirconia. At first glance, cubic zirconia and diamond look very much alike. Both are clear, shiny, and solid at room temperature. However, diamonds and cubic zirconia do not share all of the same properties. For one thing, diamonds are the hardest naturally occurring substance that we know of, so they are very hard to scratch. In fact, diamonds are often used in saws to cut very hard things like stone. Cubic zirconia is not as hard as diamond. It can be scratched easily and isn't nearly hard enough to cut through stone. Diamond and cubic zirconia are also different in other ways, such as melting point. Diamond and cubic zirconia have different properties because they are made of different atoms. Diamond is made of carbon atoms packed together tightly, and its chemical formula is a single letter C, which stands for carbon. Diamond is always made of carbon atoms stuck together in a repeating pattern. Cubic zirconia is made of groups of one zirconium atom and two oxygen atoms. Its chemical formula is ZrO2. This atom group repeats to make up a cubic zirconia gemstone. If a gemstone is made up of atoms other than carbon, chemists can tell that it isn't a real diamond. Substances are made of atoms or groups of atoms that repeat. The number and type of atoms that repeat are different for different substances. Diamonds are made of just carbon atoms repeating. Cubic zirconia is a different substance because it has a different group of atoms that repeat. All substances are made of groups of repeating atoms, but these groups can take different forms. In some cases, like ethyl butyrate from orange juice and isovaleric acid from sweaty socks, these repeating atom groups form separate units called molecules. Individual molecules are not connected to the molecules next to them. Many of the substances that you encounter every day, such as air and water, are made of individual molecules. In other cases, like cubic zirconia and diamond, these repeating atom groups link together to form large networks known as extended structures. In extended structures, the atom groups repeat over and over again, with all of the atoms connected to their neighbors. Besides diamond and cubic zirconia, there are many other substances made of atoms that form extended structures, such as graphite, metal, and even salt crystals. However, whether they form individual molecules or extended structures, atoms are the basic ingredient that make up every substance and determine its specific properties. Differences at the atomic scale are what make substances look, smell, and feel the way they do.